All right, we are up and recording. So welcome back. Probably going to spend a few nights on this. For all of you guys that are in physics already, this is probably going to be pretty easy and straightforward for you. But in BC, there is some coverage on the topic of vectors. So this kind of just starts right at the beginning. So again, I get for a lot of you guys, this is probably pretty easy, but we'll start from the beginning. And a vector's definition for what we're interested in is it's a quantity having direction and magnitude. And then I gave a different word for each one of those. So for the direction, we're going to be talking about slope. And for the magnitude, we're referring to length. And down below, we have the notation for some of this. So a couple ways you can express a vector. So if we were discussing vector V, we could do V with an arrow over it, or we can do a bold-faced V, and both of those mean the same thing, which is vector V. So that's just various ways to notate that. And when we look at this graph here, we have our initial point that is showing it 0, 0. And then this is going to extend outward in some direction. And then wherever that concludes, that point is called the terminal point. So we have an initial and a terminal point. Okay, so up above, we mentioned the word magnitude, and the magnitude is the length of a vector. So this is the symbol for it. It's two vertical lines on either side. And then whatever you're finding the magnitude of, that vector would be on the inside of that. And essentially, this is just nothing else than really, it's just Pythagorean theorem, if you think about it. So the formula for magnitude, so now this is if we had vector V. The formula is x2 minus x1 squared plus y2 minus y1 squared tucked underneath a radical. So when you think about it, that's basically the Pythagorean theorem, right? That's like saying the differences in your x's, the differences in your y's. And when you square both of those quantities and take the square root, that kind of mimics finding either distance or finding the hypotenuse of a right triangle. So magnitude is going to be the length of a vector, and this is our formula for that. And then we also want to know that speed is going to be the magnitude of velocity. So speed is the magnitude of velocity. All right, turning the page, we'll have you guys start with one. So for an example problem, it says let vector V contain 0, 0, and that's going to be going up to 5, 2. So that's your initial and terminal point. Find, and then you need to understand that notation because that might just be all that's written. That notation is telling us to find the magnitude of that. And if this was compared to the last one, where this was speed, you could also make some connections with that. But for right now, we're just going to have you guys go ahead and find the magnitude of that. So take about 60 seconds and then we'll talk. Okay, so we should be saying that the magnitude of vector V is going to be equal to, and then we're going to do a square root symbol. And then what's going on underneath that square root symbol is that we want to subtract the x's. So that's 5 minus 0 squared. And we want to subtract the y's. So that really is going to work itself out to 5 minus 0 square. That is 25. That is 4. So we're coming up with radical 29. Okay. Next is component form. Okay. So this is written up here. The component form of something is when you do the subtraction of the x's and the y's, and you just get one ordered pair. So if it's written with these sideways brackets, this is called component form. And component form is you're only going to get one ordered pair, and that ordered pair is the subtraction of those two. And go ahead now and answer both pieces of this. We're finding the component form, and we are also finding the length. What is the length? Another name of saying that's another way of saying the magnitude. So find the component form, and then also find the length, also known as the magnitude. So we're going to say that vector v is equal to the subtraction of the x's should give us, so depending which one of these we call this, it's x2 minus x1. So when we look at this, which one's which? The terminal point is this one. So when you look at the picture, the marker just died here. Here we go. When you look at the picture, the original picture we looked at, now this one's different ordered pairs, but it was the initial was your x1 and your y1, and then the terminal was the ones with the twos on it. So this is technically for the first one, 1 minus 4. So that's -3. And then the other one is 2 minus -6. So that gives us 8. So for vector v, our component form would be -3 comma 8. And then when we go to find the magnitude of that, that's going to be the square root of. Now, think about what we've already found here. This is x2 minus x1, and this is y2 minus y1. So if you're given component form, you can just take these two numbers and you can just square them. And that's just kind of saving you a step. So when you do that, that's going to be 9 and 64. And then what does that give us? The square root of 73. Does anybody have any questions out there as of yet? Okay. Next up, so we're going to give you guys some time here to work through these. Go ahead and copy this down at the top, and then I'll slide the paper up so you can do more. It says let u, vector u, be -3, 7, and let vector v be 5, 1. And we want to note here that vectors in component form are going to start at the origin, and the terminal point is the ordered pair. All right, so there is, let's see, there's 8 problems on this page. We're going to go through here and have you guys do 4 of these at a time. So with what you had, we're looking to figure out the following operations. So for the first one, it says that we want to do -1/2 times vector u. And these are pretty much straightforward. Like what you think is what you get. So this is just take -1/2 times each piece of that ordered pair and then just create a new one. And then for this next one, it's going to be the same thing that you just found in part A, but we're going to find its magnitude. And in the third one, we're going to go through and perform addition. And in the fourth one, you're going to find the magnitude essentially of the answer from part C. Okay, so I will stay quiet here for 2, 3 minutes, go through, see what you get for these vector operations, and then I will post the answers to these 4. Okay, go. Okay, so here are the results that we've got for the first 4. So while I leave that up there, do we have any questions on how we're coming up with any of those? Okay, I will take your silences. We're good then. Um, and then we got 4 more. So let's look at E, F, G, and H. So go ahead and take a couple minutes on those. All right, so for E, F, G, and H, we've got results showing there. Um, excuse me. Any questions, guys, on anything here that you're seeing with vector operations?
Are we supposed to be able to know how to do 29 squared in our head?
No, I don't think so. So this set of problems was just copied out of a textbook, to be honest. I don't think they would ever give you anything that big. That said, if you really wanted to try to find it, I mean, my mental process behind that would be do 20 of them first. So, 10 of them's 290 and another 10's 290 and kind of go from there and break it into pieces. But no, I don't think you would see anything that big.
I mean, it's not tricky. We can just do it. You can write it out, but
Yeah. I think that's bigger than what you would see on a EP exam.
okay.
Okay, next up, we've got something called a unit vector, and a unit vector has the same direction as the original vector, but it has a length of 1. And the formula for that is going to be the vector over the magnitude of the vector. And this is called a unit vector. So down below, we've got a formula for you and we've got an example problem. So go ahead and give this a try. So for the most part, I mean, today is just intro to vectors, is just going to be learning some formulas. And then once you know the formula, this isn't too bad. Okay, so showing this math, you've had the points that were given for vector v was 7, -3. And then when you put this over top of the magnitude, the magnitude ends up being radical 58. And then basically, since you want to break this back down into vector or component form, you can kind of just split these and put them both over radical 58. And then if you were to actually show that this length is 1, you could go back through. You don't necessarily have to do this, but I did it just for conversation's sake last year when I was doing it in class. You can show that the distance and length by using that magnitude formula, it does in fact work out to 1, which is kind of what the definition of this was for a unit vector. For what the question was asking, though, the answer is right here. The rest of this is just kind of showing you that it does work. Okay. Next up, we've got something called a dot product. And a dot product is when you multiply two vectors together, you get what is called a scalar number. And a scalar number is essentially just a singular. We're going to put this all together and get one result, one number. So for a formula here, if you have u, vector u, and vector v, and you want to multiply them together. You are essentially multiplying the x coordinates of each and the y coordinates of each, and then adding up that result. So we would be multiplying the x coordinate of each and the y coordinate of each, and then we would be adding them up. Okay, and below, we've got some example problems. So we've got let u be 2, -2, and let v be 5, 8. With that said, we want to find vector u times vector v, vector u times 2 times vector v. We want to do vector u squared, and for the last one, vector u times vector v squared. So I will stay quiet for about 5 minutes and then we will post some answers. Go ahead and try them. Taylor, what's up?
I'm sorry, can you just move the page back up for a second? I'll take a photo. I just missed some of it. Cool, thank you.
Mm-hmm. All right, let's go through here one by one. So for the first one, doing vector u times vector v. So when we do 2 times 5, that's your 10, negative 2 times 8 is negative 16. Combining those results is negative 6. For the next one, we have vector u, and then just off to the side, you want to do 2 times vector v, so that's going to change it to 10 and 16, and then you would run the same process as what we just did in the first one, and that gives us a result of negative 12. For the third one, okay, to find u squared, you're essentially multiplying u times u. So u squared is going to be vector u times vector u. And when you run the process on those ordered pairs, that should come out to be the number 8. And finally, for this last one, so off to the side here, we want to find vector v squared. So it's the same thing as what we did up here. It's just that it's only applying to what's in parentheses. So you would go off to the side and do vector v squared, so 5, 8, and 5, 8. And if you do 5, 8, 5, 8, that's 25, 64, so that's 89. So v squared is essentially 89. And then if you take each one of those times 89, you've got 178 and negative 178. Okay, so I don't want to flood you guys with formulas. There's still a lot more coming with this vector stuff. My advice is to watch this video again and do these problems all over again and just kind of digest it and practice it a little bit. But once you get your head wrapped around, there's just a bunch of formulas, but once you get them, there's nothing really bad here or too crazy. So I'm gonna probably just cut it there. We do get into derivatives and integrals and all sorts of stuff with vectors, so we'll jump into that as we keep going. But for the basics, let's see here. Yeah, that's pretty much the end of where stuff would be considered like intro basics. So I think that's a good place to stop this for part 1. So just try them again when you have some time between now and Thursday, maybe spend a half an hour on it. Do you guys have any questions for me?
No, thank you.
All right, sounds good. Enjoy your, is tomorrow your first Mr. Nickley class?
Yeah.
Sounds good. All right, enjoy your first class with him. If you guys need anything, let me know. And our next class is Thursday night, same time. So I will see you guys then.
Thank you.
Thank you.